Hey everybody, my name is Jay Gordon. Welcome back to the Azure Cosmos DB Global User Group. This is about you, the developer, the Azure Cosmos DB user. We want to hear from you. We want you to be part of spreading the word, getting the most out of Cosmos DB, learning the stories about your successes. It's what we do here. It is what I love to do because I want to hear from you. I want to know what you have been building and your different successes that you've seen. So if you want to be part of one of these sessions, well, don't worry, I've got a way for you to do it. You go to this form, you fill it out, and I will get your submission. We'll start working together and we'll hopefully get you here on this show. But to get you on this show, I got to work with someone really, really cool. And that person is Askia. Hi, Askia from the Reactor. How are you today?
I'm good, Jay. How are you doing?
It's early for you, for me, more for you than me, but you know, hey, we're getting this day start off really, really well.
That's right.
So, I know, Askia, before we do one of these, you always have a little housekeeping for me. So, let's clean house.
All right. Well, thank you, Jay. We would like you to take a look at our Sorry, it's the wrong way. Basically, at our code of conduct, and what that says, we posted in the chat. Basically, what it's saying is that we seek to provide a respectful environment for both our audience and presenters. We encourage engagement in the chat, but we ask that you be mindful of your commentary. Please remain professional, and if possible, please try to stay on topic. We'll definitely be sharing useful links throughout the chat, so keep an eye out for that. And we want to let you know that this session is going to be recorded and will be available on the Microsoft Reactor YouTube channel, usually in about 24 to 48 hours after our session has concluded.
Fantastic. So we're looking to hear from you all today, sharing in the chat. Askia, you always know how important it is for people to give us their questions.
Yes.
I know it makes this an interactive session. You can watch the YouTube video of it later. However, if you got questions, you want to be part of it, we'll be able to answer them directly. So Askia, thank you so much for getting us started. We'll be about an hour and I'll see you at the end. All right. Cool. So we've gone through our intro and I have one more little thing to remind you. And that is Azure Cosmos DB Conf 2025 is on April 15th. If you'd like to go ahead and register, go to aka.ms/Azure Cosmos DB Conf. You'll get reminders, things like that. I'll be sure to drop that in the chat and you'll be able to click it directly. But before I do that, I want to bring on someone that is going to be our guest today. And it's someone that's doing some really great stuff around our Python SDK. And to be honest with you, there are so many developers out there that still need to understand what Cosmos DB does, how it works, and it basically is the database for developers. So one of the people that works really hard on making sure that Python is the best it can possibly be for Cosmos is Theo Van Cree. Hi, Theo. You are a principal program manager on the Cosmos DB team. We work together all the time. Welcome.
Thanks, Jay. It's good to be here.
I'm glad to hear that. So you've got a lot to show us today. And so I'm going to keep these little pleasantries and everything very short for you. I don't want it to take up too much of your time because there's so much for everyone to learn. So I want to just get everybody up to speed. Theo, you've been at this for many years, and you've been in different roles. I saw you recently post something about how being a coder really wasn't where you started. It's something you evolved into. You want to talk a little bit about that for me?
Yeah, I was actually the other way around. I started as a developer.
Sorry about that. I misread it.
No, it's okay. It's kind of a confusing post. There was a lot of things in there. I started as a developer, and for many years I thought, that was the important thing, and I wanted to be a daemon coder and everything. And I guess the post was about how there are a lot of things involved in putting software and applications together, and I guess you could call it the sort of little tidbits of wisdom that I've acquired over 20 years of hacking around with computers, I guess.
Got it. Well, you definitely are here to show people how they can hack about computers today, and specifically working with NoSQL and working with Python. I know that the Python SDK for Cosmos DB has really taken a lot of steps forward. There's still more work to be done, but you can kind of give us an introduction to it today, and we can kind of learn more about how our Python developers can work best with Cosmos. So that being said, Theo, I'm going to bring up the presentation, okay? So when you're ready, just let me know.
Yeah, I'm ready now, hopefully.
Great. So if you've got questions, people, please put them in the chat. And as we go through this session, I'll see if when I can get them to Theo. But until then, Theo, why don't you take it away?
Yeah, so I hopefully you can see everything okay. Welcome to the fundamentals of using Python with Azure Cosmos DB. Like Jay said, I'm a PM in the Cosmos DB team. We work together. Most of my focus is SDK. Well, all of my focus actually now is SDK, connectors, AI integrations, developer experience, and so on. And I've been working on the Python SDK for some time now. What I'm going to go through today is quite a lot, so we'll see if I manage to get through all of it or not. I'll start with a little quick intro to Cosmos DB. I'm not going to assume that everybody knows what it is. Maybe you've just happened upon this session and you know something about Python, but Cosmos DB is new to you and you're looking to understand how to use Python with Cosmos DB in the best way. I'll start with some basic features, getting started type stuff, and then we'll move on to some more advanced features. It won't be a complete compendium of everything that you can do. That would certainly take more time than we've got here, but I chose some of the things that are being used now by some of our bigger customers who are working with Cosmos DB at scale with Python. So hopefully that will be interesting for folks. And then if I have time at the end, we'll see. I'll go over a quick flyby of the Spark connector and writing Python with the Spark connector and using that for processing big data at scale with Cosmos DB. Right, so Cosmos DB, in case anybody doesn't know, of course, this is Microsoft's globally distributed NoSQL offering. It's built from the ground up to use commodity hardware and multi-tenancy with resource governance at the software level to optimize resources available in Azure. And as a result, we can offer a multitude of SLAs and capabilities to our customers, which they depend on. And as of today, Cosmos DB still has the most complete set of SLAs, performance and availability-based SLAs available in the market. And it's no surprise that many of, in fact, most, if not all of Microsoft's applications, certainly the ones with a global presence, are running on Cosmos DB and storing their transactional data there. These are just a few of them. And of course, I just included ChatGPT in there. OpenAI uses Cosmos DB to scale ChatGPT and store its messages and so on in there. So why use Python on Cosmos DB? Well, like I already alluded to, it's pretty much the database of choice for scalable, globally distributed apps. Python is really hot right now. As everybody knows, it's very popular, and people are prototyping a lot of different types of applications in Python. Python SDK for Cosmos DB, mostly by virtue of it being Python. You developers won't need me to tell you that Python is a very easy language to prototype things in. And of course, if you're using it with Cosmos DB, that unlocks the high performance benefits that it brings. And of course, like I just said, it powers state-of-the-art Gen AI applications such as OpenAI's ChatGPT. And incidentally, Bloomberg Intelligence recently identified Cosmos DB as pretty much the go-to database for LLM, large language model customization, and RAG pattern in particular, if you're building AI apps. More about that later. All right, so let's cover just the basics to begin with. Setup, installation, connection, and CRUD operations, and so on. All right, so I have just a PyCharm project here. I'm going to go ahead and create a new project, just brand new from scratch, vanilla, nothing in there already. And then I'm going to go and search in Python packages for Azure Cosmos. Of course, you can do this from terminal with pip install as well, but I'm going to do it here because it's nice and easy. You can install the latest version. It's not quite the latest version. This is a recorded demo, so latest would be something like 4.10.1. But nothing has changed since this. So we're going to go through there, create a new simple file, main.py. And I'm going to go ahead here and use GitHub Copilot to do everything for me. So we're going to see how good that is. I'm going to start putting comments in describing what I want. So first, I want to create a Cosmos DB client and create a database and a container if not exists. There you go. Copilot is even anticipating what I want. So it's importing a Cosmos client with exceptions. And then it's going to, as I tab through, I'm just encouraging it to do things. So it's going to initialize the client, give me a couple of environment variables here. I'm using key-based auth. We generally recommend default Azure credential or similar secrets and so on, but this is okay for a demo. So it's instantiating the client, it's passing in the credentials, it's going to create a database name and pass that into create database if not exists on the client. Again, it's coding this all for me, just based on the comment. There might be a few things you need to do, like import a class here, imported partition key for that, and then it's just going to print out the database ID. I think it's just going to give me the container ID as well. So it's pretty much done everything for me. And then I am just going to say, right, I want to create an item, and it's created a dictionary, which will be compatible with the JSON structure that Cosmos DB expects. Cosmos DB stores JSON documents, and then it's going to give me an upsert item and pass in that item, that dictionary that I just defined. And that's pretty much it. It didn't manage to guess the environment variables where I have my URI and account key stored, so I have to change those in this case. But that's pretty much everything. I hardly had to edit anything. Copilot did all the work for me in this case. Pretty basic stuff, but still pretty convenient, hey? All right, so I'm going to debug this down to that line, and then I think I'm just going to step over that line. And then that's done, and you can see it's created a database and a container, pretty simple stuff. Of course, well, not of course, it might not be obvious, but in this case, if I'm using key-based auth, I can create the database within code, but if you're using Entra ID, these resources would need to be created already. So I'm using an emulator. I used an emulator for this demo, the Cosmos DB emulator that's available in 2 different forms or 2 different flavors, actually 3 different flavors now. There's the legacy emulator that runs on Windows. You can also run that same emulator on Linux. And then there's a new Linux emulator, which we're called the vNext emulator, which also runs on Apple Silicon and other and pretty much any operating system, albeit with a subset of the features that this emulator has. I'm using actually the vNext emulator here. So just take a look at what that inserted. Pretty simple. The items that I defined, plus you see some system properties there, etag, self, and so on. So that's pretty much straightforward. So what about if I want to query items in my database? So again, I'm just going to type out a comment and let Copilot do the work for me. Query these items. Of course, I only have one item, but imagine that I have more than one. Select star from C. If you're familiar with SQL, this is going to be pretty familiar semantics. It's pretty much very similar. The only difference is if you have hierarchical structures in your JSON document, you would have a dot annotation to traverse them. But other than that, it's very similar to SQL. I need to delete my database so that I can run the whole thing again here. Not very efficient, but just for demo purposes, I'm going to run this whole thing again. It's going to create the database and container again, but then it's going to go over my query, upsert, and then into my query, and then it's going to loop over the items. Of course, there's only one item. It should print the value of the name field, which was, I think, item 1. Yeah. So that's querying items from the database, from the container. What if I want to just read a single item by ID? Now, you might think I can just use the same thing and just specify the ID, but it's given me a different method here, or a different function, I should say, container read item. And it's passing in the item or the ID of item 1 and something called partition key of item 1. And this is where you hit one of the nuances of Cosmos DB, not actually compared to just relational databases, but also NoSQL databases in general. Not only is Cosmos DB a distributed, partitioned or sharded system, it also has both a lookup store and a query engine as well. So if you want to do queries where you're filtering by various different fields and you're doing complex, you're adding complex logic to filter out the data, then of course a query engine makes sense. But if all you want to do is get the record by ID and partition key, then there is a lookup store, and that's what you want to use. But because that will not actually generate a query plan, it will go straight to the document, and it's very fast in terms of data retrieval. And since most operations that you do on Cosmos DB, and pretty much most databases, you expect a majority, at least a large majority, to be very atomic operations, just reading, looking up a single value. It makes sense to have a different engine for doing that, and that's what Cosmos DB has. But the partition key element is also important because, like I said, Cosmos DB is distributed. Not only do we distribute data among different machines, or I should say divide the data into different machines, known as sharding, for concurrency and for performance, we also, within each shard or partition as we refer to it, we also take copies of the data, known as replication. So replication is for fault tolerance, sharding is for high concurrency and performance. Come on to that a little bit later. Again, but for now, I'll just say, in terms of the basics, just doing CRUD operations like this, the most important thing, if you're working with Cosmos DB for the first time and you're using Python or any other language for that matter, is that you read about partitioning and you understand what the right choices are to make, because it's the one thing that if you get wrong to begin with, it's actually pretty hard to course correct. Everything else is pretty flexible, but partitioning is super important. So definitely bookmark that link and read all about it before you start working on Cosmos DB if you're new to it. All right, so that was a whistle-stop tour of really the basics, getting set up, CRUD operations, why partitioning is important, and why you need to get into it. We're going to hit some more advanced topics here. Like I said, there are quite a number of advanced topics. Couldn't cover them all here, but I think these ones are interesting and important if you're using Cosmos DB at scale, which, let's face it, most customers who use it, or a lot of customers who use it, I should say, are using it at scale. It is, after all, designed for massive scale. And so I've picked 3 things here: running ChangeFeed or using ChangeFeed and why you would use ChangeFeed, how to operate ChangeFeed at scale, and also sharing session tokens, which I'll go into. And these are all features that are being used fairly heavily by our biggest customers, including OpenAI. So I think most likely, if you're running at scale, if it's good enough for them, it's probably good enough for you. So let's start with change feed. What is change feed exactly? Change feed is a distributed log store in Cosmos DB. If you're familiar with things like CDC, change data capture, it's basically the same thing. But in Cosmos DB, you have we also provide a programmability model that has publish and subscribe semantics. So you can pretty much interact with change feed as though it were a message queue. It's not a message queue. It's much more that you would have less concerns with latency interacting with change feed than you might have if you were using a message broker, let's say, but you can sort of interact with it in the same way. And what this means is if you are doing things like event computing, stream processing, building an event sourcing architecture, let's say, if your architecture is going to be homogeneous with respect to the database, in other words, you're just using Cosmos DB, it makes sense to pretty much use change feed. You don't need to use a bloated message broker in between. Of course, things like Kafka, event hubs, they're very useful if you have a heterogeneous environment. But it certainly makes sense to use change feed if you're not. And ultimately, change feed is used behind the scenes by those systems anyway. So I'm just going to use a little, start with a little demo of doing this in the vanilla fashion in the easiest way. Not necessarily the most scalable way, but the easiest way in Python to begin with. So the thing to notice here first is I'm just calling a function called query items change feed on the container, which we created earlier on. And I'm just doing an infinite loop basically here. And if there's results received, I'm printing them out. And if not, I'm sleeping. And then I'm starting the start time that I'm passing in. So basically, I'm trying to get the latest change each time, and it's continually running. So it's continually polling, you might say, the change feed. So let's just see what this looks like when it's being run, just so you can see in action in case that's not making sense. So I'm just going to split my screen here, and you can see it's running there. I'm going to the database. It's created a database and container for me, and I'm going to go into this and just create just one record, very simple, ID of 1, and just change the address here to something simple, and then save that. And we can see on the left-hand side, it's picked up that change. If I go in there and just add a field, new field, and just put whatever in there, and you can see if I update that, you can see it will pick up the change as well. So again, that's a pretty straightforward way of interacting with change feed. But of course, doing it this way, if you have a lot of partitions in Cosmos DB, which may translate to multiple physical machines, of course, it's going to read sequentially over all of those partitions. So if latency is important, or speed of moving your data from one place to another, whether it's a streaming or event sourcing scenario, you're going to want to do this at higher scale and concurrently. And that's where processing the change feed in parallel using something called feed ranges is going to be important here. What is a feed range? A feed range is a representation of the value space that is going to be processed. When you get feed ranges, which you can do in Python by calling the get feed ranges function on a container, you'll get a list of the feed ranges that are available at that time. And as I said, they represent the value space that is the total value space that is possible divided by the number of physical partitions at that time. The reason I'm kind of laboring the point there is if the number of partitions increases, whatever feed ranges you have at that time will still be valid. It's just that they may each feed range may process more than one, the data in more than one partition, I should say. So you can obviously you want to be able to get all the feed ranges that are available, and there are ways of doing that, and it's some complex orchestration involved. But if you just want to get what's available at that time, that is what this is going to do. So I'm just printing that out here, and then once I've got those feed ranges, I'm going to execute them in parallel. Now, those of you who've been using Python for some time will know you can't actually execute bytecode in parallel. Anything that's CPU bound is, of course, restricted by the global interpreter lock in Python. But you can execute I/O bound operations in parallel. So calling a database is obviously a network I/O operation. So when I'm doing a thread pool executor with concurrent futures here, I can call these feed ranges in parallel and merge the results. Not quite showing the merge results here, but once I start this running, it's just going to get the feed ranges and then execute them in parallel. Typically, what you might do, this is just for demo purposes, is you might actually have separate machines that are getting the feed ranges from some lookup area where you've already retrieved them and then processing them in parallel using the resources on that machine. But just for simplicity, this is kind of a multi-threading, quote unquote, approach that we're doing here. So let's just run this and see what we get here. So we're just going to run this little piece of code. And again, I'm going to split my screen and do the same thing that I did before. You can see it's printed out the feed ranges that are available. Now, in this particular container, I created the container with 10,000 RUs, and 10,000 RUs will actually translate to 2 physical partitions because you need at least 6,000 request units, that is, in Cosmos DB for a single partition. Haven't really covered request units, but it's all in our documentation. So it's just the way of provisioning resources in Cosmos DB. And you can see there, if I add a document, it's processing from one of the feed ranges because it's processed them both in parallel and only one of them had data available, and so it processed that data and it was able to retrieve it. You can imagine if there were hundreds of these and you had workers on different machines processing them, obviously that would be much quicker than processing all of them on a single machine. So that's that, and that's all very well. And you can, as hopefully they've given you an indication of how you might hand crank this and do this yourself natively in Python. And of course, that would actually, if you really want to do it all in Python, you want your entire stack to be in Python, that would be the most performant way of doing it. But it's complex to orchestrate, or can be complex to orchestrate. And there is another way of doing it that gives you maybe a better trade-off, which is to use Azure Functions triggers. And this will actually streamline the integration with something called change feed processor, which isn't available in the Python SDK, but is available in both the .NET and Java SDKs. Azure Functions Runtime, which is a capability in Azure for doing stateless and stateful serverless operations, actually runs in .NET and uses our .NET SDK and Cosmos DB to execute the change feed processor and also orchestrate spinning up of workers as needed when the container scales out. So everything that I was alluding to in just the previous demo is all done completely transparently for you if you're using Azure Functions triggers. There is a little bit of an overhead from the .NET runtime to the worker architecture that is exposed in Azure Functions to allow you to write your code in Python. But certainly, if you were to use this approach, it will be far, far more scalable and obviously much more transparent and easy to set up than if you're doing it the way that I showed in the first demo there. And just to show how easy this is, I'm going to show a little demo in a second, but you deploy Azure Functions into Azure with a very simple code that I'm going to show in just a minute, and that will be responsible for adding additional workers as needed and scaling up automatically based on interaction with our change feed estimator code in the background and also our change feed processor. All you need to do as a developer is just set up the functions trigger, which is super straightforward. Assuming you have all of the dependencies installed from VS Code, this is how you would do it. You just go into the Azure tab, you find the nice little Azure Functions icon, click on Create Function, select a directory, select the Python language, the V2 programming model, select your local interpreter, and you select Cosmos DB trigger. That's what we want. We're going to call it Cosmos DB trigger. I'm going to name the container that I want to monitor. And I'm going to name the database that I want to monitor. I'm going to create local app settings for me. So it's dynamically going to pick up the subscription and the account that I'm using. And then it's going to pretty much code gen everything for me. And so that it's generated all of the code. And this is all the boilerplate that you would need to be responsible for. Very simple piece of code. Like I said, all of the change feed processor and parallel processing of feed ranges is all done transparently in the background within the functions runtime architecture. I just added a little bit of code there using GitHub just to print the doc ID of each doc that's coming in from the change feed. You would need to have a Leases container available, which you can see on the right-hand side there. And that would store the metadata of change feed processing and feed ranges and so on. So just running this here, minimize the screen a little bit, just hit func start, and that will start the functions runtime, and it will acquire a lease lock on the Leases container. You can see in here, again, that familiar feed ranges concept. There's metadata being stored in each entry here, aligning to the workers that are interacting with the change feed processor. So this is all stuff that you need not concern yourself with. It's all transparent, but it's all been handled behind the scenes if you use the functions trigger for Cosmos DB to process change feed. All right, so that's doing change feed in the simple way at small scale, and a couple of different ways of doing it if you're doing it in large scale. So the next thing I want to talk about is
I just wanted it. We've got one question before you move on to change feed, if you don't mind.
Sure.
I'm not too sure about it, but Rotoso wants to know, how can you do stress tests to change feed processor method? And so I was thinking about it, and maybe you can tell me if I'm right or wrong. I was thinking about it in the context of like maybe setting up like a high ingestion environment. Mm-hmm. So like you need to be able to actually have something to test. So I would figure like you need to set up a high ingestion environment. You need to configure the actual processor, and then you might want to use like a load testing tool, like a JMeter or Apache or something like that. And then you kind of have to measure the performance and do some scale testing. Can you give any other like ways people can, because this is what I know top of head, but is there anything else you think people can do to make sure that they're getting what they expect out of change feed, all those updates, everything?
Yeah, it's a really good question, actually. I don't know if I have a really good answer. What I can say is if you are setting this up with functions, at least the setup of functions is very straightforward and transparent. So it really is about evaluating whether the messages coming in, as you say, are accurate and whether you're seeing drops or anything like that. But honestly, I don't have a good piece of advice there on stress testing it. In some ways, I hope folks rely on the fact that we stress test it and we make sure that this works. We obviously have a pipeline. When I say we, I mean the combination of our team and the functions team, and also our SDK team that builds change feed processor and ships that into Azure Functions. We obviously have our own test pipelines that make sure this is working at scale. It's an interesting question, though. Maybe this is something that we need to expose more clearly, how you can visibly see stress testing or be able to visibly see this at scale. It may be that somebody else has a better answer than I do right at the moment, but certainly internally we are doing this. It's kind of like, trust us. It's not. I know it's sort of a hand wavy answer, but obviously this is being used at massive scale by a ton of
cool. All right, I'm gonna give you back the floor. Thanks for answering that question, and if you've got more, please put them in the chat. Thanks. Go ahead.
Sure. So yeah, for sharing session tokens, which may seem like a completely nebulous topic, if you may not even know what session tokens are, to talk about this, I really have to talk about that CAP theorem. If you're not familiar with Cosmos DB or any other NoSQL or distributed database, you probably won't be familiar with this. If you are, a little refresher, I guess. CAP theorem addresses data consistency in distributed systems. In a nutshell, like I already said at the top there, Cosmos DB is distributed. Not only does it shard data, but it replicates or copies data within physical partitions for fault tolerance. But one of the trade-offs that produces is every node that is writing the data or reading the data it has a certain amount of redundancy. So if one of them goes down, obviously that's great for availability because there are others that are there to take over. But any one node being down in the system creates a consistency problem potentially. If that node comes up later, it might not have the latest up-to-date versions of the data on it. So you may get inconsistent dirty reads and so on. So then you've got a choice to make. Either you're going to say, I'm going to allow my system to just read any node that's available if one node is down because I'm favoring availability, or I'm favoring consistency. And Cosmos DB has 5 different settings for consistency. The strongest being strong, and that's where you're favoring consistency. You don't want any dirty reads on the data. You still get a certain amount of availability benefits because your reads will still be able to be served from redundant nodes, but your writes will fail in that case if any of those nodes are down and not able to receive replication. So that's the trade-off there effectively. And at the other end of the scale, if you're favoring availability, you're saying, hey, all bets are off. It doesn't matter if the data reaches any of these nodes. I just want my application to be available. So a couple of stereotype use cases where you might favor strong or eventual. If you're favoring strong, it's probably something like a payment application or a financial application where things like duplication or out-of-date data would really be a big no-no. So you might be favoring some variation of strong, or maybe local quorum or something like that. And a stereotyped type of application at the other end would be something like a social media, right? In Facebook, it doesn't really matter whether I'm getting the most up-to-date version of somebody's cat photo. It just matters that everybody is able to access the site, because you're going to have thousands, millions, billions of people accessing that kind of application. Obviously, those are extremes, but those would be the kind of scenarios. And there are a couple of other concepts that was closely related here would be recovery point objective, or in plain English, how much data could I lose in an outage? If you are favoring strong consistency, then you'd be on that end of the scale. The other end of the scale would be recovery time objective, or RTO. In other words, how long will I be down in an outage? And the real kicker here, which often is difficult for folks to stomach, is according to the CAP theorem, which I didn't really go into in any depth, you can't have both. You can't actually have RPO 0 and RTO 0, at least theoretically. So what people are always trying to do is some compromise in between. And session consistency in Cosmos DB is like a compromise in between. What it does is ensures strong consistency at the session level. So in other words, every Cosmos client, which you saw us create before, is able to read its own writes. In other words, there's no chance of it getting stale data once it's read something. If it reads something 2 minutes later, as long as the session is still open, or sorry, I should say straight away, as soon as it's written something, there's not going to be any risk of getting a stale read. It's going to get the session token that comes back from the server and make sure that the LSN sequence is up to date, and so that it can get the latest read. But crucially, without paying the performance penalty across the whole system of having consistent reads on other sessions. So this is where the trade-off comes in. You get to read your own writes, but you may not necessarily get the latest read on somebody else's write, if that makes sense. So returned with write operations, scope to partition key range for optimized performance. And it's just a way of balancing consistency and availability. So then, now that I've explained everything about, or most things about what are involved with session tokens, what am I talking about when I mean, what do I mean when I'm talking about sharing session tokens? Well, like I said, it's very difficult in a lot of cases, especially when you're dealing with very, very high throughput systems that still need strong read on the data, but also need high availability. You're really wanting that RTO and RPO to be 0 as much as possible, or as close as possible. And so sharing session tokens is really about balancing this even further. So you can, if you're able to share session tokens between different clients rather than just being with the scope of one Cosmos client, then of course a larger group of clients can get a consistent read on the data. But again, they're not paying the performance penalty of guaranteeing quorum reads across the whole database. But obviously the challenge of that is getting granular at this level, threading the needle, as it were, at this level can get complicated. Tokens are tied to partition key ranges, so they need careful handling. and sharing across multiple clients can be challenging. So what I want to show here, it's not a demo, it's more of a code walkthrough of a little convenience function that's nonetheless very useful in the Python SDK, and actually I think was first used by OpenAI, is something that will make this, or can make this easier. So in this little code snippet here, what you would first have, if you imagine on the right-hand side here, previous session token, is a session token that we've retrieved from a cache of session tokens that we've already created, which I haven't shown here, but let's say you're retrieving it from there. You would then use that to pass, well, in that previous method there, you would pass that to create item, and in the response, you would get a session token back from the server. What you then do is append that session token to the session token in your cache, and then it's, the really useful function here is to call get latest session token, because one of the difficult things is making sure that you have the latest, or you always have the latest token available, because obviously tokens are not only scoped to a logical partition, they're scoped to each client as well. So if multiple clients are creating them for the same logical partition or partition key range, then you don't know which one is the latest one. So this method makes it easy to determine the latest one, then you get that and then update that into your cache, and then that's how you can more or less easily, or at least more easily than it might otherwise be, have the latest session token for a given token range, or a given feed range available to every client that needs it. Now, obviously, if you were going to do this with every single client, then you're kind of doing the same thing as quorum reads, or using strong consistency or bounded staleness, and it probably actually would give you less availability because you put too much stress on being able to generate too many tokens and so on. But doing this at a relatively, let's say, small scale with a subset of clients, let's say it's the clients that are processing the payment aspects of your application. Maybe there are other clients that are reading the same data, but they don't have the same consistency needs. This is what I mean about threading the needle on trying to balance consistency with availability and latency and performance in a high throughput large scale system. It's a big challenge because, you know, ultimately the cap theorem is just physics. It's not a restriction that we have in Cosmos DB. Every distributed database has to contend with it. So you're always having to try and balance this off. All right. So last thing I wanted to show on the Python SDK is multi-agent AI apps with Cosmos DB and Python SDK. You might think, is this really a fundamental thing? Seems like a broader topic. Is it part of fundamentals on the Python SDK? Well, you may have seen this statement a while ago made by Satya. Traditional business applications may fundamentally change in the agent era. These applications are essentially CRUD databases with business logic, but in the future, this logic will migrate to AI agents. Caused a big stir, a controversial statement, people disagreeing with it, agreeing with it. I happen to agree with it. I think this is where things are moving. And if that is the case, then understanding agents and understanding AI and the different features involved and how they relate to the database is going to be fundamentally part of how you interact with the SDK and the database that you're using. So why Azure Cosmos DB for AI agents? Realize I'm kind of going a little bit off topic of Python SDK, but it's important to know, at least to me, why we think that Cosmos DB is a really great choice, generally speaking, for agentic apps, AI apps. Of course, it has very low latency. You heard me talk about the key value stored there and why that's efficient. This isn't very important for storing memory and state. I'll kind of demo that a little bit later on in action, why that would be important. But it's super important in this space. The schemaless nature of Cosmos DB is really important for flexibility. Of course, we've all seen how flexible large language models can be when using ChatGPT. The whole paradigm shift that has happened in terms of building applications that use large language models is the flexibility of the inputs that you can get. So you're really now dealing with natural language and an application that is able to process natural language and give outputs. It follows, therefore, that the problems that you would have had with schemaless databases in the past, interpolating changes to the schema and how that might break things. Obviously, LLMs and applications that are built using LLMs are going to be much better at interpolating those types of changes. And so schemaless databases are going to be very important as this whole space evolves. And then another reason that Cosmos DB is so great is because it's not only a transactional database, but it also supports vectors, indexes, and vector search within the same database. And it's important to be able to have both transactions and vectors together, which I'll demo as well in a little second here. And of course, scalability, availability, data locality. This is important for every mission critical app, to be honest. And we expect many of these types of apps to be mission critical. Certainly, if what Satya says is true, that they're essentially, in the end, going to replace the app tier, then of course it's important if you're building these things at scale to be able to have somewhere to go if you need to scale. All right, so I'm going to switch to my screen here. And first of all, I'm going to go to my Cosmos DB account. In fact, first I'll just show this is the sample that this is based on. I just created this a few days ago, so possibly you're one of the first people looking at this. It is actually based on another sample that we put out a few months ago using OpenAI Swarm. OpenAI Swarm is an experimental framework that's really useful for just prototyping agents and agents interacting with each other and so on. But as I said, it does have an experimental label. So we put out a LangGraph version of the same sample. LangGraph is by now a pretty mature framework for handling orchestration of agents and so on, and persisting memory and chat and in vector stores, etc. So,
Theo, we actually got a question about that too, if you don't mind.
Sure. Go ahead.
Rashmi asks, I've been exploring Azure AI lately and have a basic question. Is semantic kernel the framework in Azure for building agentic AI? Is it similar to LangGraph? I know you just brought up LangGraph, so I figured I'd...
Yeah, so that's a good question. It's an interesting the way it was phrased. Is it the framework for building agentic AI? It's one framework. Our opinion, I think, and when I say our, I think the collective Microsoft opinion would be that it's probably the best framework if you're building enterprise scale apps, let's say, or well, just enterprise apps in general. The comparisons that I've seen between things like semantic kernel and LangGraph would be saying that yeah, semantic kernel is better if you're building enterprise, let's say, more robust apps. Or I don't want to say more robust, but let's say they have more things like security and other aspects like that more built in. LangGraph is good. You can think of it more like a Swiss Army knife. It's very good for the features that it has and how you can rapidly prototype. And it is also suitable for production grade agentic systems as well. It's also very flexible as well. So maybe there's the trade-off here is that there's a little bit less flexibility in semantic kernel, but more enterprise features, and vice versa in LangGraph. More flexibility, but less enterprise features. So that's how I would contrast those two frameworks. There are, of course, other frameworks in other languages, but I think LangGraph, whose progenitor was LangChain, of course, in Python, and semantic kernel, we have a Python version of semantic kernel as well. I would say at this point in time, the Python version of semantic kernel isn't as nearly as mature as LangGraph. So if you are a Python developer, and you want to build agentic AI, I would suspect that LangGraph would probably be the best thing for you. If you really wanted to build something that's enterprise ready, it's still worth looking at semantic kernel. Eventually that will mature and it will be focused for those purposes. So yeah, that's a very long answer to the question. Hope that helps.
And we actually got one more question, and I think it's just to interpret what the meaning behind enterprise is. By enterprise, do you need large corporations? What about a startup that needs highly scalable consumer agent app that is used by millions of people.
Yeah, I was trying to be careful with my words there. I didn't want to imply that enterprise means necessarily scale. What it just means is basic features that you would expect are not boilerplate, or you know, things like security, things like Entra ID integration, and etc. Scalability can sometimes come into it, but it's not always necessarily the case. I think it is the case with semantic kernel, so that has been baked in to some degree. But I wouldn't say for a minute that LangGraph would be a significant difference in scale. Honestly, I haven't put either of them massively to the we've been looking at LangGraph on my side. We haven't really done a side-by-side benchmark between LangGraph and semantic kernel yet. From our point of view, we're just looking at the database aspect. So if you're looking to understand purely from the agent orchestration aspect, that's something for you to evaluate. But yeah, that's what I mean by enterprise. Not necessarily scale, but it's more what features are out of the box versus what features you have to hand crank yourself. LangGraph is more flexible, but it also requires a little bit more hand cranking in some areas, although less in other areas, it has to be said. So I'd say evaluate it yourself. Yeah, more or less, those are the differences that we're seeing, at least from others who have evaluated it at a you know, agentic orchestration level.
Fantastic. All right. So Theo, we got about like 10 minutes. Obviously, you can go over a little bit if you need to, but just giving everybody a heads up. Got about 10 minutes. So if you have some more questions, we'll probably get to them after Theo finishes. Why don't you take it away, Theo?
Right. So yeah, so I have my I have a database here that has a few containers in it. One container is chat, which is going to store effectively the state. It's called chat, but really what this should be called is a conversational state or application state or something like that. So it's going to store not only messages, but everything else about the interactions that happen in between an agent interacting with another agent and a user, and storing the chat information as well. And then I also have a few other containers, but before I show those, let me just go ahead and go straight into running this thing here. I'm not going to go through all of the code because the sample is available and it's pretty easy to interact with, but it's just a couple of things that I wanted to show that are kind of interesting. So let's just go ahead and run this thing. And this is just the kind of CLI interactive version. There is a chat UI as well in Gradio that you can run that runs over this. But this, yeah, it's going to connect to Cosmos DB, and it's just didn't give me a welcome message, but I'm just going to say I want some help. So the triage agent responded to me. Can you please provide more details about the kind of help you need? So this is, so far, it's a very small interaction. You just got a user message and an agent message, and that's it. If we go to a chat thing here, you see that I started with absolutely nothing, so a clean slate. If I go back into this, let's see what we have. Just for that small interaction, we already have 16 documents. So you can see here, chat systems, agentic AI systems that are maintaining state for conversational AI or interactions of a similar nature are going to be, quote unquote, forgive the pun, very chatty. So obviously it's important for whatever system is persisting state to be able to be very performant and very low latency and be able to handle a lot of high concurrency. If you've got a lot of users interacting with this thing, of course, that is super important. And in here, I didn't show this earlier on, but just lower down here, this is actually implementing the checkpointing feature in LangGraph with Cosmos DB. And it's using Cosmos DB as the persistent state storage. So this data can be persisted over a long period of time. And so if you need to have what we call long-term memory in an agent, then this is the kind of thing that you would want to be doing. Obviously, there's a limit to what you can store in memory in something like this. So the next thing I wanted to show was just, okay, it's asking me what kind of help I need. Tell me about your smart phone, oh, can't type, products. It's transferred me to a product agent, and it's executing vector search in Cosmos DB. And so this is an example of using the RAG pattern within an agent and going to Cosmos DB to get the data. But the thing I wanted to show here is it's getting the data from a products container, but this container isn't just a vector store. Like I was saying before, it's important to be able to have your transactional data and your vector data in the same place. I don't just want to use this to help answering these questions. I'm also using this as my product catalog. So it's going to have my pricing, my not just the description, which has been vectorized here for use with the RAG pattern there, but also the product ID. And I'll be updating this and cross-referencing this from other containers. So it's a transactional database. So I don't want to be re-indexing everything every time I want to update my vector index. It doesn't make sense efficiency-wise to have two different stores, one storing my vectors and the other storing my transactions. Why not have them in the same place? And that's what Cosmos DB, something like Cosmos DB that is both a transactional store and a vector store, makes it very useful for this kind of purpose as well. So I don't know. Let's just, for fun, let's just look at the UI and see how that works as well. Again, you can try this sample out for yourself. It's pretty easy to get running. Let's see if this works. The danger of doing live demos.
The demo guides, they're either kind or nice, but I can actually, I got a question for you if you want it while you're waiting. Rashmi asks, how does it choose which agent to run?
Oh, that's a good question. Great question. So
based on sentiment or something?
Yeah. So in this scenario, there's actually two ways that I'm doing it, and there are different ways of doing it. I don't want to imply that there's just one way of doing it. But in this way, what is happening is there's a function or a capability within LangGraph called tools. So you can call a tool. An agent can call a tool. In this case, I'm actually creating a tool that actually handles the transfer to another agent. So within the tool itself, let's find it up here. I think it's right at the top. Yeah, create agent transfer. So when it calls that tool, it actually creates a tool dynamically to transfer to another agent and calls the command function to be able to then route the graph to another agent. So the way this is expressed, this whole sort of conversational experience is expressed. Each agent is actually expressed as a node in a graph with edges connecting those nodes. So you run the command tool to route the agent from one agent to another, and I'm calling a tool to be able to do that in this case. There are other ways of doing it. So you could have, for example, in fact, I do have that here for the triage agent. Let me find the triage agent. Where is it? I'm looking for the call function for the triage agent somewhere down here. There we go. So for this, instead of calling the tool, I actually am storing the active agent in the database. So I have a separate container called user data where I'm storing the active agent, then retrieving that in order to deterministically route back to the last active agent if the first agent is the triage agent. The reason for this is actually for something that we're going to add to this sample later on. If you're having a turn-by-turn conversation, it's actually being exposed as an API. But anyway, there's different ways of doing it. The more native or the more, let's say, best practice or generally the recommended approach is the one that I showed earlier on. You'll create a tool and you'll use that tool to do the routing between agents. And then the tool is called dynamically from the agent, which is defined as a react. So this concept of reason and act, a react agent that is able to call tools and dynamically extract information from the text that's being passed to it in order to figure out which tool to call. And then this particular tool will route to another agent. So Nothing to do with Cosmos DB. That's just all about agentic orchestration in LangGraph.
Sounds good. So we got about a few minutes left. Do you still have a little bit more to go? Tell me what you want to finish up with.
Yeah, I had an entire section, but I'm definitely not going to have time to go through that. But I actually pretty much covered the same information in another session. So I don't know if you want to advertise the Python session.
Theo, we've got the opportunity next month to do a whole other session to kind of continue that content. So I feel like if everybody wants to see that, I definitely would love them to. Rashmi, the repo should be the comment before from the reactor. You should be able to find it there. It's the multi-agent GitHub swarm right there, github.com/Azure Cosmos DB/multi-agent-swarm. All right. Well, I'll give you a chance to kind of close up what you're looking for, and then maybe we can talk about doing the next section in the future.
Yeah. So let me finish. Let me at least show a couple of things that I wanted to show. Really, just useful links for people to follow. So definitely check out the docs for the Python SDK. Of course, there's a lot of interesting, fun stuff in there. It's very verbose, and there's a lot of information here. So really, if you're just looking for samples, definitely recommend that you check out the Azure SDK for Python. Look for the SDK folder, and then go and find the Cosmos folder in there. And then you'll see Azure Cosmos, which is the name of the Python module. And then there's a samples folder in there. There's pretty much everything that you can think of is covered by these samples. And then if you want to find out what we're actually working on, I would definitely encourage you to interact with us. We've actually made our roadmap public. So again, if you go and look for Azure SDK for Python, you'll see a projects folder in there. And under Cosmos DB Python ecosystem, we have a board view and a roadmap view, and you can just go and click on there, and you can see everything that we're working on along with timelines. And we try and keep this pretty up to date. So go into those issues and comment on them if that's something that you want, or if you're not sure, if you want to check that the timeline is still good and everything, we encourage interaction. And also, if you want to raise issues or feature requests in the SDK, definitely encourage that as well. We're investing a lot of time and effort in improving the Python SDK. So we definitely encourage interaction and contributions as well. It's an open source SDK. So if you want to contribute, we'd be more than happy to see those and review those. A couple of other resources, of course, there's the Cosmos DB GitHub account. There's a bunch of nice resources in there. Last but not least, or second to last but not least, I think, the Cosmos DB samples gallery, pretty awesome stuff available in there. Multiple different programming languages. Of course, you can filter by Python. We've got a lot of Python samples available in there. And yeah, that's pretty much me done, I guess. I don't have time to talk about PySpark, but yeah, let us know in the comments. Vote it up if it's something that you want to hear about, and maybe we can do another session on that.
Yeah, I think a great session on like PySpark, analytics, things like that would be really interesting, and how like Python users can make use of that. Really great stuff, Theo. I really enjoyed this, and I know our viewers, like, we sustained a really great audience today. People really seemed interested, and I'm glad that you were able to give this. And Theo, we're going to try to do a few of these. I know we were talking about it, and I really think that this audience loves to hear what you have to say, especially we've got a whole world of Python developers, especially that regularly visit the reactor, that just want to hear more and more. So you definitely got them on that right road. But to help bring us to the road home, I've got Askia. Hi, Askia. How are you?
I'm good, Jay. How are you?
Great. All right. So I'm going to bring up your deck, and you can go ahead and bring everybody to the end.
All right. Well, thank you, Theo. Thank you, Jay, for a great session. Hopefully you all felt the same way. Oh, is not cooperating today. Hopefully you felt the same way, except for my PowerPoint skills. But we would love your feedback. So if you could take a moment and complete our reactor survey, the most important thing with this is just the event code, which is 24898. Once again, 24898. We will take all your feedback into consideration and give you the shows that you're looking for. So we appreciate it.
Thanks, Husky. I appreciate it. Theo, you've got some talks and stuff coming up soon, don't you? Like a JD Conf and...
Yeah, I'm speaking at JD Conf, which is a Java Microsoft conference. So I'll be talking about AI with Spring. So if you happen to be a Spring developer that's wandered into a Python session, then I'll be talking about similar things to what I talked about at the end there. In that conference.
Hey, we want to bring in every developer possible into the fold. So Python, Java, JavaScript. Hey, Rust. I know, Theo, the preview of the Rust SDK came out, and I know there's a lot of people that are going to be interested in that. So if you haven't already, please check it out. Anyway, everybody, that's it for this session today. We hope to have more for you in the future. I know I'm going to be talking to Theo about getting more about that PySpark and learning even more about how you can work with Python and Azure Cosmos DB. But until the next time, let's go ahead, everybody. Let's give them the big wave goodbye. Thanks a lot, everybody, for taking part, and we'll see you next time. Be good to one another, and remember, use Azure Cosmos DB. Bye now.
That's it.